Now let us look at another problem. This is a geometric problem known as closest pair. Now till now what we were seeing the sorting problem, or we were seeing a searching problem. But this is a geometric problem known as closest pairs. Now here this comes in the category of brute force. So we will look at what is the problem with brute force and how can we rectify it using divide and conquer. Now assume that we have an x and y plane, or a two-dimensional plane of x and y coordinates, and we have several points. Now the problem is, or what we need to solve, we need to find who is nearest to whom. That pair we have to find. Which pair? Which point is nearest to which other point? That is closest pair. That is what we call it. So what we do is we will divide. Let us first look at brute force approach. What will be the brute force approach? Brute force approach means without thinking optimally, efficiently, we try to find the solution to the problem. So here, this is geometric, what do we say, points. Every point has its x and y coordinates. So finding the distance between the 2 points is nothing but we use Euclidean formula, that is x2 minus x1 whole square plus y2 minus y1 whole square divided by 2. And whole root of that. So that gives us the distance between 2 points. So what would be the exhaustive or brute force approach? Brute force approach would be to take 1 point, find its distance to all other points. So if there are n number of points, you take 1 point, find the distance to all other points, n points. That runs for n times. Then take another point, find its distance to all other points n times. So if there are n number of points, and you find with each iteration, take a point and find with n number of the distance with n number, then the time complexity of the brute force approach would be n square. That is the brute force way of computing the closest pair. And obviously, O of n square is not that efficient. So, is there any better way? We use divide and conquer approach for closest pair. But divide and conquer approach says that, and it gives us better time complexity. What divide and conquer approach says that divide the elements into 2 partitions. And this is not based upon half. It is based upon how many elements are in left side and how many elements are, how many points are to the right. So once we divide it, we have a partition as A, and let's call it as left partition with all the points on the left side, and the blue dotted line is the, what do we say, is the x-axis, the value of x, which divides these points. So we are not dividing the points based on value of y, we are dividing based on x coordinate. And let us have the next partition as B, 2 partitions A and B. B, all green dots comes into partition B. So this is the divide approach, divide and conquer approach. Then what we say is find, or recursively find, the smallest distance between the pairs, closest pair, in partition A, partition B. So again for partition A we can divide, partition B again we can divide, till there are only 2 elements. So when there are only 2 elements or 2 points, that means the solution is small. And we can directly compute the Euclidean distance. So instead of taking all n number of points and trying to find distance between each point, we divide it only till we are left with only 2 points, and we can easily find the distance between them. There's no loops or iterations involved. Now assume that partition A, point B and H is the minimum. distance. Let's call this the AD. So recursively we assume that we found, we again recursively applied this closest pair part, divided this array A, partition A into again half, again half, again half, assume that we found the minimum distance between among all the points in A, that is the red dots, as D of A. And then with B, respect to B, the partition B, assume that we divided and we found the smallest distance between the pair J and F. Let's call it that D of B. Then we combine. Now we try to find who is minimum between the pair in A partition and pair in B partition. So minimum of, we select D. D is nothing but delta, or sometimes it's called as D. D, the distance between minimum of distance of A and distance of B. That is the elements from partition A and elements from partition B. In this case, let's consider D of B is minimum. Then this D, whatever is the distance, minimum distance we found, from the partition line on x-axis, we will have another line drawn with a distance of D, even to the right side, even to the left side. So blue dotted line is the dividing line. We create two more imaginary lines, less D distance and greater D distance, the delta distance. Now, all the other points which are towards the left or towards the right of these two has to be ignored. And we consider only this region between the two yellow lines, which are D apart from the midline. Why? Because there is no need to consider other things. They are definitely, if you join the points from this region to any other region, obviously it will be greater than D distance. And we don't want this. We found the minimum till now is the D distance itself. So what we do is, we only have these many points now. So actually, when we divide a line, we have three cases. The smallest, closest pair can be in partition A, or closest pair can be in partition B. So these are the two cases. The third case is that the closest pair, one point of the closest pair can be in partition A, and the other point of the closest pair can be in partition B. Using dividing approach, we have found what is the closest pair between in A, what is in B. Now we are trying to find if there exists a closest pair whose one point is in region A and the other point is in region B or partition B. So now we have only left with these points. So we select point vertically, y-axis, we select a point, the highest point, and then we compare this box, blue box which you see, we try to find whether a point lies between these two boxes. What is this boxes? The width is D itself, because that's the blue line. What is the height? From D, vertically distance of D, and vertically to the top and vertically towards bottom. So we get this region as the rectangle. Now we only, at the most, what we have to compare is 6 extreme points. Those are the 6 extreme points we have to compare. These 6 extreme points. Now, none of the points here will lie within this shaded region of A side. If it lies, that means what D and DB, what we computed, is wrong. So we don't have to compare the points among the ones which lie in the shaded A region. We only have to compare points which lie towards the shaded B region, and which will be at most 6 points. At most 6 we have to compare. Now in D, does any point lie within this region? No. Then we select the next point in region A, within the shaded region, that is the red one. Are there any points which lies within this region of the blue two boxes? No. So that means we have not yet find anything closest than DB, that is JNF. Then we have the last point I. When we draw the region of the 6 point from I, point L lies within that region. So we found the closest pair which is closer than J and F, that is the distance dB, closer than the distance dB. So this is how the closest pair algorithm works. So the brute force approach is to take one point and compute the distance with all the other points. So that runs for n times, and for n points we have n square as the time complexity. And the other approach is divide and conquer approach, where we divide the region into two halves and perform the divide and conquer strategy as we have seen now. So this was all about closest pair.